everyone. So before I start, I mean, it's a long title, right? What happens to your data architecture when a query layer starts making decisions? And I kind of want to be honest about why I'm framing it this way. My initial thoughts were, okay, let me call this talk something like building agentic analytics or maybe like future of semantic layer. And then I decided to kind of scrap them both and go with this long title. Um, I think I want you to leave the room thinking, hey, it's not agents or it's not analytics per se, but rather it's this whole architectural shift that we're kind of having underneath. Um, you'll see this here stated as a subtitle, right? Which is the query layer used to be a function, it's becoming a policy. And I think that single sentence, I would say, is the whole talk. Everything I'm going to say is basically unpacking, what changes when that kind of becomes true. So let's kind of hold on to that subtitle. So let me pull up the slide. So the picture I want you to have in your head is what's on the left, right? There's a SQL query. Um, and you have some data at some moment, and you kind of press go, and you get a number. We've done this same query, same data, same number, right? And this is like the most boring property of a database, right? It's so boring that maybe there's not even a name for it, right? But it turns out almost everything we've built on top of databases for the past 2 decades, right? Um, I would say even DBT or Iceberg or any of the audit systems, all of these things are basically, in a sense, silently kind of leaning on this whole property, right? And then shift to the right, right? You now have an agent. What's going on is natural language goes in, and a model is going to emit a tool call, and then we have a query that runs, and the result kind of comes back. Your model kind of thinks about it, and this emits another tool call. Eventually, you get a number, right? So if we run that loop maybe 10 times with the same input, you're not going to get the same SQL, right? Typically, you'll see, depending on the model and schema, maybe 2 to 7 different queries, right? Uh, and I think this is kind of fine if you happen to get the same number to like different paths, but it's not fine if you get different numbers, right? Because actually, maybe the scary case is where you actually get the right number 9 times and the wrong number on the 10th, because by the 10th call, you actually were able to calibrate your trust on this thing, and you put this in production or evals, and you actually have the worst outcome, right? So let's kind of, I mean, we know this typical thing, right? Which is um, the result of any query at a time t is basically a function of query, a schema, a data, and your time, right? So that's our function. It's one number, 4 arguments in, one number out, and it's pretty deterministic, right? And the moment you kind of write it like this, you basically see it everywhere. Warehouses are gonna assume this. My lakehouse assumes this. DBT tests assume this. Even iceberg snapshots or everything. Maybe your incident run book also kind of like assumes this. And every governance policy that we've ever shipped, all of these kind of implicitly, given some sort of an authorized caller, the answer is a function of these 4 things, right? It's not a feature, but you might call it as a load-bearing assumption underneath this whole stack, right? Or rather, the entire stack, right? So when this assumption kind of changes, when the answer actually becomes a sample instead of a function, then every layer above it gets a little wobbly, and most of those layers, they probably don't know that yet, right? So the picture here is DBT Labs benchmark from earlier this year, right? There were 11 questions, and they did 20 runs each, and there were these frontier models, insurance data set, and there was one question, uh, the same question, same data, and you get this whole fan out, right? The thing I want to point out, and it's kind of subtle, is this text to SQL. It doesn't fail the way we would kind of hope it would, right? Normally, I would kind of hope it would fail pretty loud, in a sense like, hey, your parser was blowing up, or there was a big red error, and yeah, I mean, those are the ways I would hope it would fail. But it actually fails as a long tail, right? So the average accuracy that you have on your leaderboard might look fine, or may you can say it may look great as well, but the variance that you have across different runs, that's what is going to kill you in production, right? Because in production, the user does not see 10 runs. Maybe the user just sees one run, and they don't get to average over 20 or 10. So here's the thesis that I'm kind of like mentioning as flatly as I can. Um, the query layer used to be a function, but it's becoming a policy, right? And the reason this matters is because every architectural assumption of downstream queries have been deterministic. And now we have to re-examine, right? Uh, let's take governance or observability or cost attribution, testing, like all of it, right? So um, I think what's important is determinism actually breaks, right? And there's also, we may have to make some architectural decisions here. And hopefully not a lot of frameworks, and I'm not going to make any vendor pitch here, right? So okay, first section. So where does determinism actually fail, right? I think the naive failure mode, where maybe everyone reaches for the first, is uh, my LLM basically writes a bad SQL, right? And yeah, I mean that's I would still say that's a boring case, right? I can catch a bad SQL with a parser, or maybe I can have a query plan inspector uh, with my Cloud Code, right? And that's actually solved. That's maybe end of 2024, early 2025 problem, right? The interesting failure mode is the one I want you to take seriously, which is when an LLM actually writes a plausible SQL that kind of returns subtly different numbers across different runs, right? And this is a one where your current stack gives you basically zero signal on, right? And yeah, so let's take this question, right? uh, Maybe we're trying to answer this question: what was Q1 revenue? um, it's one to sentence, it's 6 words, right? Including the question mark maybe, or and the way I want you to think about this is, look at how many decisions the agent has to make before it actually writes a single token of SQL, right? uh, when you think about calendar, which calendar is it, right? Is it fiscal? Is it actual? Um, Depending on region as well, right? And your finance team's fiscal Q1 might end, I don't know, end of Feb, and your product team's Q1 might end of March. And if you're now counting regions, different regions, your fiscal years end differently, right? So both of them real, both are in your system somewhere. And it depends on who's asking and for what purpose, right? Similarly, revenue, right? What do you mean by revenue, right? Is it booked? Is it billed, right? If you take a look at a SaaS company, right, these can differ by maybe 10 to 20% at the end of any quarter, right? So uh, similarly, right, if we think about customers, right, is it paying customers at the end of the period or paying customers right now? I think you get the scene, right? So when you actually multiply this out, it's actually something like 128 interpretations, to the minimum, right? And the way a senior analyst would handle is they would slack a finance person, and the finance person has a sheet, and they're going to give you exactly uh, how they computed it, and then you're going to use that to write a query, and that's how you get your answer. Mm, Pretty deterministic, right? Now the way an LLM handles it is you sample it from a distribution that's kind of conditions on whatever happens to be in that prompt at that moment, right? So that's exactly what's happening. It's actually a sample, right? So now, I mean, moving to the subtle part, right? I think the part of this room is going to recognize, with your own systems. If you go look, is these are two SQL queries, right? Both of them are kind of labeled Q1 revenue, and both run by an agent, right? And two different numbers, right? None of this actually shows up in your existing tooling or your query log, right? They're two valid SQLs, and they both parse, they both run. Your warehouse cost dashboard, they're two valid bills. Even if you think about your DBT tests, they all pass because both reference kind of like real columns and both kind of produce real numbers, right? So every signal in your stack is going to say everything's fine, and the only person who would have caught it is this analyst who you could have spoken to, or maybe a deterministic pipeline, right? And now that we're relying on agent, kind of like we've removed that sensor and the system is not able to call it, right? Now, this is what I kind of mean when I say governance, right? The way we've kind of practiced governance for the past 2 decades, it doesn't really account for something like this, right? Governance is a question about who can read what, or who can write what, or who can grant what, right? That's I mean, I can go on about the vocabulary, but agents basically makes access necessary, right? um, Kind of important, not sufficient, right? I think the new question we should be asking ourselves is interpretation, right? The two callers with identical access, and they're kind of producing different answers from similar data or identical data, right? So uh, I think the access control just gives you no purchase on that, right? 'Cause it's not the wrong tool. It's just a tool for a different problem that you have. And the three failure modes that I wanted to mention, and the reason I'm kind of being a little careful about this is one is there's a generational drift, right? Uh, we just saw different prompt context, different sample, different SQL. That's very easy to think about, right? And then the second one is plan drift, right? It's much more subtle. The agent is not going to write a query, it writes a plan, multi-step, and on retry, maybe step three becomes a different operation than what step three was in first attempt, right? If you're logging at the query level, you won't see this, right? You see two queries. You don't see they belong to two different plans, right? And the last one is what I would call something like a silent contamination of context, right? And I think this is the worst one because the model is going to pick a filter early in the session. It was wrong. And now every subsequent answer in the session basically carries that filter forward, right? So every answer is basically consistently wrong in the same way. Um, from a user perspective, I think this can be indistinguishable from being right. So, and I might say that zero of these are detectable by our current stack, right? And it's not a model quality problem, right? Models are going to get better. I think this is an architectural problem. Now, I think this is the part I think there's something to do where we can have maybe three decisions for each one. So decision, reasoning, and a pattern. Um, I think we can make things that can work in production, right? So let's go to decision one, right? Can we move the contract and not this warehouse, right? Mm, yeah. The default thing, the thing everyone reaches for first is you give the agent execute SQL, right? Describe schema or list tables. And then the agent goes and reads the schema, writes the query, and runs it, right? This is a text to SQL with extra step, right? I would suggest not doing this, right? The pattern I see working is um, to make the contract between this whole probabilistic system and the deterministic system explicit, right? Which is mm, uh, maybe this comes to how we think about agent's primary tool surface, right? So that's governed by a metric API and not a raw SQL. So once you have a model that picks a metric, the SQL is generated by a compiler, not a model, right? Um, I think you have metric flow, you have Cortex Analyst, at scale. They're all converging on the same idea. And the way to think about this is, agent's choice space basically stops being something like, any SQL string the model can possibly emit to uh, which metric, which dimension, and which filters, right? I think the picking is probabilistic. That's fine. The SQL it produces is going to be deterministic in this case, and that's like the whole game, right? And for DBT benchmark, right? I think the questions that are going to basically fall on the model scope. I think text to SQL had that long tail, right? So now you can actually pose a very obvious objection um, is, hey, no, the semantic layer can only answer questions inside its scope, right? So what do you do for everything else? And the answer I see working is a tiered tool surface, right? Let's say we take a tier one where there's a semantic layer over MCP. So three tools, like maybe in this case we can list metric, describe a metric, query metric, right? And then the model is strongly steered to kind of prefer this. So this hits like about 85% kind of a regime in production. And for tier two, there's a constrained SQL executor you can have in a read-only sandbox, right? And this can be against a subset of tables that are kind of curated. This is exactly the tables an analyst would actually use for this domain. So you have some bounded blast radius. And then coming to tier three, you have the full warehouse. It's used very rarely. It's gated behind a human approval, and it's kind of like logged pretty loudly, right? The model sees all these three, and the system prompt tells it, when to use each one of them. So now it's a routing problem, and the nice thing about routing problems is you can evaluate them. You can measure tier one hit rate. Um, you know, yeah, I think maybe there's some things there like let's not expose query metric as a single tool. Let's not instead we can expose like maybe uh, a list or a describe and query as like three different tools, and basically put this whole metric definitions and any business meaning in like your plain English, because the model is going to retrieve uh, on the description, right? Skimping on any kind of descriptions is like number one reason I've seen an agent kind of picking the wrong metric. And yeah, uh, moving on to a second decision you can kind of make. Um, so we want to make agent traces primary data and not telemetry. Um, I think the natural instinct is when an agent is answering a question, it needs a bunch of context, schema, right, freshness, all of that. And the natural instinct is library. Even I've seen the libraries also push you toward is let's kind of throw a vector store at your data dictionary, right? And kind of maybe back 6 months ago, you would rag all over it and you would call it a day, right? So a vector store does not kind of give you this unstructured retrieval. It also doesn't give you joins as well, right? And think about freshness. Do you get that with it, right? I think the thing that really matters is, so does it let you reconstruct even after the fact that the context that the agent saw at the moment, it made a decision, right? Because that reconstruction is basically a non-negotiable, right? So If you can't answer that, you can't debug, you can't audit, and you can't improve as well. So the pattern is a metadata lakehouse, right? You can have open table format, iceberg, or hoodie. It doesn't matter for the argument, right? Three layers on the same storage. Um, I think the governance layer, for example, and the question I always get is why a lakehouse and why not a graph database? Because this kind of looks graph shaped, right? And the answer is the shape of your workload as well. Because agents at any meaningful scale produce hundreds of millions of metadata events per day. Now, I think we're kind of running out of time, so I'll just say I'll make it a little more shorter. So the third decision, right? So I think this is probably the deepest one. So every agentic system has a determinism boundary, right? Um, and above this line is the probabilistic stuff, the LLMs, agent loops, retrieval, ranking, all of that. And below there's a function, and above sample, right? So now where do you kind of draw this line? And I've seen that the probabilistic system basically picks the metrics, then you emit any kind of a structured request, and the model never retouches this result except to format it, right? Um, Now each bleed here is like a sampling decision, and by the time a user kind of sees this answer, uh, you know, your model, the number has basically been touched by the model many times. So um, yeah, so how do you know if you've basically drawn the line in the right place? I would say maybe do a cheap test, take the same agent request, the same context, uh, and run it twice. Yeah, I'll share this deck, but yeah, I mean, here are some patterns based on what I just mentioned. I kind of draw the line correctly. Um, yeah, finally, let me kind of skip over the synthesis. But yeah, three takeaways, right? One, run the replay test, pick the questions your agent answers in production, right? Ask each one 10 times maybe, and compare those numbers. The variance you find is a problem. And if you don't find variance, maybe there may be a blind spot there, right? And three, look at your trace storage. I think is it your primary data? Is it lakehouse? And think about it and move it. Yeah. Um, I think MCP is your wire, right? It does not define determinism. Uh, it does not define governance. Use it, but don't confuse a wire with architecture. Yeah, and I think the architectural job is how do we keep the boundary in the right place as that shape kind of shifts. So yeah, that's a talk. Thank you.
Well done, my man. I have to tell you a little secret. I've been quoting the last time I saw you give a talk. I've been recycling and parroting what you said on the multivariant runs of coding agents and then seeing which one passes the most tests. Thought that was brilliant. Again, now I've got more stuff to steal from you, so thank you. Uh, I am a much more, I at least appear to be much smarter after watching a few of your talks.
Thank you.
We've got a question coming through here that I want to ask, and then we're going to have a little AirPod giveaways. Or did I just say iPod? What are we in 2003? No, AirPod giveaways in the break next. But before we hit that, Tosh, we got some questions for you, man. How do you
All right.
ensure that your agent traces, being primary data, are not going to push your agent to go deeper into its mistakes?
Hmm. Yeah, I think those are good questions. So one thing I would like to say is when you have your agent traces basically being your primary data, right? I think it's uh, you're kind of thinking about uh, let's just say most teams kind of when they start logging agent traces, right, they're trying to do the obvious things, right? Mm, and let's say the agent kind of asked a question and you got an answer and you kind of make that available. Now the problem is these traces are kind of like a record of what the agent did, not a record of what the agent should have done, right? So if an agent kind of picked, in this case, maybe uh, status is not refunded on Tuesday, uh, then you kind of the correct filter probably was maybe a hammer status not in refunded or chargeback both. Then you feed the trace back into context, right? So that's a positive feedback loop on mistakes. So one a couple of things I would kind of think about doing is don't feed raw traces into your retrieval context without having some sort of a quality signal, right? Um, and maybe another thing is how do we separate observation from interpretation, right? When you have a trace that should record like, hey, the agent emitted the sequel and the warehouse returned this result. Uh, that's an observation, right? It should not record this is how you answer Q1 revenue questions, right? That's an interpretation. And maybe finally, I kind of wanted to touch on this topic, but um, can we actually use semantic layer as a ground truth anchor, right? Then, uh, you know, when it disagrees, you kind of mark it for review. So yeah, so I would say, treat traces like medical record, maybe not as a prescription. Yeah.
I like that semantic layer as ground truth. That was something I had heard a few other people talk about that. So we've got one last question for you coming through, and it's basically no matter how much of this determinism layers we add, we always need a human in the loop, right? Or
Yeah. Yes. I mean, I guess hopefully AGI is going to help solve that. But yes, I think most likely we'll have humans in the loop. I can speak for the next 5 years.
excellent. Well, Tosh, dude, this has been great. Folks are asking for the deck. So if you can drop it in the chat, we also are going to be sending it out an email to everyone. And all of the decks that we have and we've gotten the approval to share, we're going to share with folks. So sit tight after the event. But look, Tosh is just one step ahead of me. What was that noise? Oh my gosh. Uh, so there it is, folks. If you want it, you've got it right here. Grab it, click on it. There we go. Now, Tosh, I'm going to kick you off. We're going to have this little break because somebody.